What's going on, everyone? Today's objective is that I can make a residual plot and interpret what it means. All right, so we're going to be talking about residuals, and let's get into what exactly a residual is. So a little bit of notes, and the diagrams are good to have. So a residual is the difference between the y value of a data point and the corresponding y value from the line of best fit. So basically, if I take the y value, as we just said, so if I take the y value, let's go red. If I take the y value from the actual data point, so let's say if this was my y value from the actual data point, and I took the y value from the point on the line, I would have what we call a residual. So the actual y value minus the predicted y value. So the residual for this like little cluster of data right here, these 2 points. So the residual would be the actual y value, and the actual y value here is 10, minus the predicted y value, which is 8. Therefore, the residual would be 2. Now, a smaller residual tells us how close the point actually is to our line of best fit. So how well our line actually is measured based on our data point. So I'll repeat that again. So smaller residual tells us that our line of best fit models our data very closely. So it's a good fit for our data. All right. And it appears that the line is going to be a pretty good fit for our data. But that is where we get residuals from. Okay. So after we find a residual, we plot it on a different point, and we plot these residuals that we have here. So this graph that we just saw is the basic graph that we will have. So it's the basic scatter plot and our line of best fit that we will have. This is the residual plot. A residual plot shows how well a linear model fits the data set. If the residuals are randomly distributed on either side of the x-axis and clustered close to the x-axis, then the linear model is a good fit. Okay. So these points are pretty closely clustered to the x-axis. Some of them may seem like they're kind of far away, but notice how they're all really within 2 units from the x-axis. That's pretty good for the data set that we had. Okay, so they are all pretty close to our data set. Okay, so that's going to show us that we have a pretty good linear model. Okay. So whenever I was looking through Regents problems, and really whenever we're dealing with residuals, they're not super complex. So I'm just going to go through an example of one that we have here and how we can go ahead and use it. So I'm going to have my graphing calculator nearby just so I can do some computations. All right, so here's the problem. Student enrollment at Blue Sky Flight School over 8 years is shown. The owner used a linear regression to determine the line of best fit. So this is the line of best fit from the data. The equation for the line of best fit is y is equal to negative 35x plus 1,208. Okay, so what we want to be able to find, the predicted value and the residual. So in order for us to find the predicted value, we're going to use that equation. Okay, because that equation basically is a prediction. So I'll write right here. So this is our predicted value. And then afterwards, we will find our residuals. All right, but first let's go ahead and find what these predicted values are going to be. So I have x values, and I'm going to substitute them in to my equation. So I'm going to start with 0, and I'm going to substitute it for 0 right here. All right. So if I substitute 0, I will end up with 1,208. And I'm going to round all these to the nearest digit. All right. If I substitute 1 into my x value, I'll have negative 35 times 1 plus 1,208. So 1,208 plus negative 35 is equal to 1,173. I'm going to keep going, inputting different values. So I'll have negative 70 plus 1,208 is 1,138. Negative 35 times 3 plus 1,208 is 1,105. Negative 35 times 4 plus 1208 is 1,068. That is a 6. Negative 35 times 5 plus 1208 is 1,033. Negative 35 times 6 plus 1208 is 998. And negative 35 times 7 plus 1208 is 963. Okay, so we have our actual values, which are right here. This is students that we had, the enrollment. And we have the predicted values. Again, we found the predicted values by using our equation for our line of best fit. Now we're going to find our residual values. And remember what we said before. We said that residuals are the actual y values minus the predicted y values. So let's do some subtracting. I have 1235 minus 1208. So therefore the residual is going to be 27. 1178 minus 1173 is 5. 1,115 minus 1,138. That's going to be a negative value, a negative 23. 1,102 minus 1,100 and 1,000. Make sure that I have my values right here. 1,102 minus 1,100 and how did I get 5? Negative 35 times 3 plus 1208. Yeah, that should be a 3. Okay, good. I was just checking. That should be a 3. Will give us a negative 1. 1,020 minus 1,068 is negative 48. 1,050 minus 1,033 is 17. 1,003 minus 998 is 5. And 978 minus 963 is 15. Okay, so here are our residuals. Now, when I make my residual plot, I am going to take my x values and I'm going to use the residuals as my y values. And I'm going to go ahead and plot them on a coordinate grid. Now, I couldn't make a residual plot here, but I'm going to put them on a coordinate grid. And when I put them on a coordinate grid, here is what we will be given. So notice that 0 should be a little more than 20. And if I look back at my data, for x being 0, the residual was 27. That works. So therefore, when x is 1, the residual should be about 5. So x is about 1. The residual is about 5. Or x is 1, sorry. Residual should be about 5. And that seems to be pretty on point. So this is the plot of my data sets. So let's take a look. Does a linear model fit this data set? Well, take a look at all the points that are so close to our data set. So close to our x-axis, I should say. This one's very close. This one's on the money. Very close. Very close. And even these two are rather close. So this is pretty close. This is pretty close. We only have a couple that are kind of far off. And because they're, randomly distributed but close to the x-axis, that tells us that a linear model would fit this plot very well. Okay. So what you are going to do is I'm gonna put another one up for you to do, but you are going to find the residual plot. I'm going to give you a set of data. You are going to find the predicted value, and you're going to find the predicted value using the line of best fit. And then you are going to try and make a residual plot. Now, one thing that I want to note for you, notice how my residual values, they range. So what do they range from? They range from as little as negative 48 to as high as 27. So be careful when you're making your graph here. So notice how my plot here goes down a little past negative 40. So it really goes to negative 60. So this is a negative 60 over here. So it goes below that just so that it fits in the negative 48, and it goes high enough that it fits in the 27. All right. So just pointing that out there for you when you were making your residual plot. Always take a look at your residuals, note the highest value, note the lowest value, and then we're gonna see if you could scale your graphs correctly, and then we'll go over it tomorrow all together, okay? But there it is for you, and I will see y'all tomorrow.